what I intend to do here is some exercises with exponential models, some examples with exponential models. So the fictitious town of Zwitzville, okay? I don't know whether a real town of that nature exists or not, but it's a fictitious town made up for this problem. So if there's a Zwitzville somewhere, pretend it's in another state or another country, okay? So Zwitzville had about 1,400 people in the year 2010. It has been growing at about 3.6% annually. A, create a model for the population. B, predict the model in 2035, round the nearest 100. Okay? So, before we do, so here's the idea, okay? Exponential models are based on the assumption of a percent growth or percent increase, okay? So, amount equals original value equals original times 1 plus or minus r to tth power, okay, where this is percent change as decimal. Okay, so since we're doing population, we could either do capital P or capital P of t. I propose capital P of t. So the original amount is 1,400. We're going to base this off the number of years since 2010. Years since 2010. Okay, so 1,400 times 1 plus, the reason it's plus is because it's growing at 3.6% annually to the tth power. Okay, so P of t equals 1,400 times 1.036 to the tth power. Okay, B, 2035 equals 25, so t would be 25. Okay, the year 2035 says t is 25. Why? Because this is 25 years after 2010. All right, so P of 25 equals 1,400 times 1.036 to the 25th power. Now, most calculators, you could just enter this in exactly as is. 1,400 times parenthesis 1.036, your generic exponent button, 25. This was what it would look like on the calculator that I'm using. Okay? So, this is approximately 3389.4. Okay? But to the nearest person, that because it's population, okay, we normally round this to the nearest whole person. 3390 people. But to the nearest 100, as population, we normally round the nearest whole person. But the directions say to round to the nearest 100. So if we're rounding the nearest 100, that is 3,400 people. The nearest 100, 3,400 people. I'm going to be graphing 3 exponential functions. I'm going to check this. I'm going to check off. I'm going to be checking off as we go along. So here goes. First of all, we're going to notice that there's going to be a horizontal asymptote. There will be a horizontal asymptote at y equals 1.4. There's a constant, that is the horizontal asymptote. Okay? We can go ahead and apply at this point if you want. It'll be a little bit less than 1.5. All right, that's going to be a line that the curve never touches. It's going to approach on one end but never touch. All right, and then I let x equal -1. I let x equal 0. I let x equal 1. I'm going to use that for all three examples, these 3 points. Okay? So, y equals 1.75 to the negative first plus 1.4. This is what they make calculators for. Okay? So, 1.75, generic exponent button, -1. I get approximately 0.57 plus 1.4, and that gives me 1.97. So my first point is -1, 1.97. All right, next step. Y equals 1.75 to 0 plus 1.4. All right, well that's 1. Anything in the 0 power is 1. So 1 plus 1.4 is 2.4. So 0, 2.4. All right, the third one. Y equals 1.75 to the first plus 1.4. Anything in the first power is itself. So 1.75 plus 1.4 is 3.15. So we have 1, 3.15. Okay, so I have -1, almost 2, not quite 2, almost 2. 0, about a little bit less than 2.5. And then 1 and 3.15. Okay, remember folks, this is going to be curve shaped. So, that's 3 points and that's all you need. Okay. Example 2. So we've done example 1. Now we'll do example 2. All right. So here's another one. First of all, there will be a vertical asymptote. There will be a horizontal asymptote. And y equals 0.4. It's a little bit under a half. Okay, and again, we're going to use x equals -1, x equals 0, x equals 1. So, I'll take 0.35, raise it to the negative first power. I'm sorry, this will be 0.35 to negative first plus 0.4. So I have 0.35, raise it to the negative first power. I have approximately 2.86 plus 0.4, approximately 3.26. So we have -1, 3.26. All right, at x equals 0, we would have y equals 0.35 to the 0th power plus 0.4. That's going to be 1 plus 0.4, 1.4. And then finally, y equals 0.35 to the first plus 0.4. Well, that's 0.35 plus 0.4, 0.75. So this point is 1 and 0.75. And this one is 0, 1.4. All right? And having plotted the asymptote, we'll go ahead and take care of the points. -1, and just a smidge about 3 1/4. Maybe about right here. All right. So, 0, 1.4. and 1, and about 1 and 3/4 of the way up. Remember, it's going to have to be a curve because it has to avoid the asymptote. All right. So example 2 is out of the way. Okay? So let me show you what we have. Possible shapes. We have this. We have this. No lines. Okay? Those are the possible shapes. Example 1 was this. Example 2 is that. All right, the third example. I think I'll pause the recorder. Here's the third one, okay? First of all, there will be a vertical asymptote. Sorry, not vertical asymptote, a horizontal asymptote. At y equals negative 1.7. Negative 1.7. See why? So, it's going to be negative 1.7 about right here. All right. You can label it or not, it doesn't matter. Okay, so remember that E is approximately 2.7, 1828, 1828459. Use shift or second on your calculators and ln, the natural log function. Okay? It may look like on IN on some calculators. Okay? So, on calculator. So, x equals negative 1. We're going to use the same numbers we had done before. All right, so y equals 0.65 times e to the negative 1 plus first power minus 1.7. So that'll be 0.65 e to the 0 minus 1.7. So I'll take e to the 0 first. So shift ln 0. That gave me 1 times 0.65. So 0.65, this 1 times 0.65 is 0.65. So subtract. We have negative 1.05. So the first point is negative 1, negative 1.05. This one will be y equals 0.65 to the 0 plus first power minus 1.7. Well, that gives me 0.65 to the first minus 1.7. So, oops, I forgot. There's an e there. I need to rewind. I need to do this again. There's an e there. So 0.65 e to the 0 plus first power minus 1.7. Okay, that'll give me 0.65 e to the first minus 1.7. So we'll take e to the first. So shift ln, shift or second ln, e to the first gives me a number that looks like that, and then take it times 0.65. Okay, I got approximately 1.767 minus 1.7. Okay, that gave me 0.067. So 0 and 0.067. And then x equals 1.
y equals 0.65 e to the 1 plus first minus 1.7. 0.65 e squared minus 1.7. So, I'm going to need to tilt the screen down, looks like. All right. And then we're going to take e to the second, so shift ln, or second ln, and then square it. That gave me and then take it times 0.65. I got approximately 4.8 minus 1.7, 3.1. So 1, 3.1. Okay? So, negative 1 and a little bit under 1, 0 down here, negative, I'm sorry, it needs to be on top. It's positive. But not very high up, because it's not much higher than 0. And then 1, 3.1. So 1 the number line, and up a little bit more than 3. There we go. And I'm done.
Okay, I'm going to talk about interest. All right? We'll start with simple interest before we move on to more complicated types of interest. So simple interest, I equals principal times rate times time. This should look familiar from your school days, where principal is the amount of the starting balance on the account, rate is R as a decimal, converted to decimal form, and T is the time. So, $2,320 is borrowed at 18.75% for 6.5 years. A, find the interest. B, find the accumulated value of the account to the lender. Okay? Because why is the accumulated value of the lender? Because they're going to get $2,320 worth of payments out of you plus the interest. Okay? So A. Okay? P is 2320. R is 0.1875. If you don't remember how to do this from school, just take the percent form and divide by 100. Okay? And T is 6.5. 6.5 years is 6.5. So I equals 2320 times 0.1875 times 6.5. Okay, so 2320 times 0.1875 times 6.5. $2,827.50. B, accumulated value is the $2,320 that will be repaid plus the $2,827.50. Equals $5,147.50, or $5,147.50. Okay? I'm going to pause here and put up other types of interest formulas. Okay, here I'm going to discuss other type of interest, okay? Compound interest. Compound interest has two subtypes, continuous and periodic. Now, some courses include periodic only, okay? College algebra classes, business math class, advanced business math classes, applied calculus classes, which is also usually business calculus, usually include both of them as well. I think it's easier to start with continuous, so that's what I'm going to do first. Okay? So, but I will at least give people an idea of what this looks like for later, okay? So accumulated value equals the principal, and then this is where things change, become different between the two of them. E is a constant. It's 2.71, it's approximately 2.718281828 and then it goes all over the place, forever, okay? You'll hit shift or second, you'll hit shift or second ln on your calculator to get to that feature, okay? For periodic, it's 1 plus, the array is a decimal, and this is still time. This is what causes the most confusion because it's usually never given as a number. Okay? It's a number of compoundings per year. Now if it says it's compounded monthly, there's 12 months in a year, so n would be 12. If it's compounded annually, there's only 1 year per year, so n would be 1. If it's compounded quarterly, there's 4 quarters in a year, so n would be 4. And semi-annually, that's every half year, so that's twice a year. Okay? So, Purple Grove offers 4.45% interest compounded continuously. If 1,040 is deposited now, find balance in 9 years. So do. It says it's compounded continuously, so the appropriate formula is the continuous compounding formula. Okay? Now, before I start plugging things in, I try to identify what the variables are, what the variable values are, because sometimes it's not as simple as it seems. So 1,040 is what we're starting with. That's our principal. We're looking for what the balance is going to be, an accumulated value in 9 years. Rate, either move the decimal point over 2 places or just divide that by 100, is 0.0445, and t is 9 years. So A equals 1,040 times e to the 0.400, e to the 0.0445 times 9th power. Okay? Every calculator handles this differently. So what I would recommend you do is multiply this out. Okay? So leave the e, 0.0445 times 9 is 0.4005. Okay. Now, on my calculator, which is a Casio, you will see, and you will typically see an LN button. On my calculator, it's right there. Some calculators, it may look like a capital I, but it's actually LN. Okay? Right above that LN, you will see e to a power. Okay? Now, I can't get this thing to focus. Okay? But above, you should be able to find e to a power if you hit shift or second. So, for me, I would just type in 1,040 times shift or second, depending on what your calculator says, ln. So again, 1,040 times shift or second ln. Okay? This is what it looks like on the calculator that I'm using. Okay? And in the nearest set, that's 2 decimal places, 1552, sorry, 0.27. Okay? Now for this one, it's still continuous. A equals PE to the RTth power, where A equals, P equals, R equals, T equals. Well, rate is still what it was before. T is 9. Now that 1,600 is what we're hoping to have in 9 years. That is an accumulated value. We don't know what we're depositing, what we're starting with. As I said, determine what your values are before you start plugging things in. So I want to know when 1,600 will equal E the P times E to the 0.0445 times 9th power. Okay, that's my unknown. That is what I'm solving for. So what I'm going to do is, since that's my unknown, I'm going to switch the side and move it over here. Okay, so I have P. I am going to go ahead and simplify the exponent. I'm going to pretend that I don't know what the answer to this is. So 0.4005 times 0.0445 times 9 gives me 0.4005 equals 1600. Now, my goal is to undo, I got P times this E to something. I'm going to do the multiplication by dividing. And yes, that is the arithmetic division symbol, and that's what I'm going to use. So P equals 1600 divided by E to the 0.4005 power. Okay, so I'll do similar to what I did here, except instead of timesing, I'm going to divide. So 1600 division, shifter second, ln, 0.4005. This is what it looks like on my calculator. Okay, if I can get it to show. Again, I'm sorry the lighting isn't very good in here. Okay, not for this. I have to darken it because I want the board to be very visibly clear. Okay? Maybe this other calculator will be a little clearer. Yeah, that looks better. Okay, hit enter or equal. Okay, so the nearest cent, that's going to be $1,071.98. The problem also said it wants the nearest dollar. So the nearest dollar, that is $1,072. Unless given reason to do otherwise, unless given reason to do otherwise, assume nearest cent. Unless given reason to assume otherwise. Okay. Purple Grove Credit Union offers 4.55% interest compounded monthly. Okay, if 1,040 is deposited now, find balance in 9 years. So it is a non-continuous. That means it's monthly, it's periodic. So this is the appropriate formula. Okay? So A equals, P equals, R equals, N equals, and T equals. So it is 12. It's compounded monthly. Okay? The rate is 0.0455. Time is, in this context, 1,040 is deposited now, find balance in 9 years, and we're starting with 1,040. We don't know what the accumulated value will be in 9 years. That's the question. So A equals 1,040 times 1 plus 0.0455 over 12 to 12 times 9th power. Okay? I strongly recommend you clean this up and never round. Never round. Okay? Never round that. Never round. I'll erase that, but I want to make sure it gets read. Never round. If it doesn't terminate, if it's a repeating decimal, then you keep it as is in parentheses. Okay? That's 108. I'll pretend that that's simply 108. So A equals 1040. That, and I'm going to see if that divides cleanly. I don't think it does. So 0.0455 divided by 12 plus 1. So what I went ahead and did is I went ahead and took the 0.04, divide first, then add. Okay? And as you can see, there's a bar on top of my 6 that tells me it repeats forever. Okay? So that doesn't divide cleanly. So I'm going to leave it as is. Most problems will not round cleanly, so I recommend you get in the habit of just leaving these in parentheses. Okay, now most calculators, this isn't going to be a problem. You just type in the 1040 times, open a parenthesis. I'm going to say that again. 1040 times, open a parenthesis, 1 plus 0.0455 divided by 12. Balance the parenthesis, and then generic exponent button 108. So the nearest cent I got $1,565.09. Okay, unless given reason to assume otherwise, you will round to 2 decimal places to the nearest cent. Okay, so for this one, same formula. Okay, so A equals, P equals, R equals, N equals, and T equals. So the cumulative value is going to be 16. So it's compound monthly, so N will be 12 throughout this problem. The rate is 0.0445 or 0.0455. Sorry, my brain was still on the last example, on another example. T is 9. And this 1600 goes with the future value. We don't know what we're starting with. That's the question. Okay? So I want to know 1600 equals P times 1 plus 0.0455 divided by 12 to 12 times 9th power. Clean that up, and since P is my unknown, I'm going to switch the signs. Okay, and I hope everything is still visible on screen. It is, good. Okay, so P times 1 plus over 12, that's 108, equals 1600. Okay, so my dream is to divide this off, because I got P times a whole bunch of stuff. So I'm going to divide off that whole bunch of stuff. Okay, so P, that looks more like a D, I'm sorry. P equals the 1600 divided by 1 plus 0.0455 divided by 12 to the 108th power. Okay? If you're using a Casio and most Texas Instruments calculators, this is not a problem. If you're using one of those calculators that doesn't support the order of operations, this is a little dicey. Okay? But for those of you who are using a good calculator, this is not a problem. Just type in the 1600 division, parenthesis. Very important that you include that parenthesis. 1 plus 0.0455 division 12. Balance the parenthesis, your generic exponent button 108. To the nearest cent, I got $1,063.19 rounded to 2 decimal places. Okay.